Yesterday we were discussing about effect of temperature on materials. Okay, so just 1 second. So when materials are get heated or cooled, we observe some physical changes that take place. Most solids and liquids and gases, they expand on heating, children. So yesterday we have discussed about a few things like a railway track, why there are gaps in between the railway tracks, the metallic strips will be there, expansion of metallic strips we have gone through. Okay, so we have discussed about these things, and even the big pipes in the industries, they supply the water. So these pipes also have expansion, they expand. So they have gaps in between, they are fitted, they have gaps, so they allow to expand. Even these pipes also, if they are not allowed to expand, they'll burst. Okay, and even we have seen the bimetallic strips which are present in iron and fire alarms also, we have learned yesterday, so how they work. And even we have discussed about the glass, how it reacts when we pour hot water, and when it is very cool and when we pour hot water into it, it breaks. Usually glass won't break. When you just pour cold water and when the glass becomes cool, and then suddenly if you just pour hot water in that, then it just breaks. And even you can see it in the case of thermos, in which you usually keep water or tea to keep it as very hot. So in that case, you must be very careful. If you're pouring hot water, then suddenly if its temperature is not reduced, then if you pour cold water, then it will break. It is because of contraction and expansion of the substances. So is this clear, children? Effect of heat energy on liquids. So we have discussed about these in our in yesterday's class, children, how the gases react to the heat, how they raise up as the volume of air increases, the density of air decreases. So the warm air, it raises high. So because of that warm air, the hot air balloon, it floats in the air. And even we have seen the application of heat energy in the case of gases in this bread, preparation of bread or cake by using the baking powder. Usually in the baking powder, we have carbon dioxide gas, which is released from the baking powder. So it makes the bread to expand and the dough to raise, and we get very soft bread or cake. Okay. So here we have even discussed about the expansion and contraction of solids. So how it takes place. So, and now yesterday we even have started regarding the solubility also. So we'll discuss in detail about solubility today, children. So what is solubility? I asked you to write it, note it down in your books yesterday, so you have noted down. The solubility, what is solubility? The maximum amount of solute that can dissolve in a known quantity of solvent at certain temperature is its solubility. The amount of solute which is being dissolved in the solvent. What is solvent here? Solvent is the water, and solute is the thing which you're adding to it. Solute might be a salt or sugar. In a solvent, you're dissolving it in a solvent. Now solvent is water at a certain temperature. Solubility also depends on temperature, children. Today we'll see how it depends on temperature. I'll show you a video so that it will be clear to you to understand what solubility is actually. Okay. Just one second, I'll just stop this slide share.
Solubility. Solubility of a substance is its maximum amount that can be dissolved in a given quantity of solvent. It depends on the nature of solute and solvent. It is also dependent on temperature and pressure. Solubility is defined as the number of grams of the solute that saturates 100 grams of solvent at a given temperature. It has no units. Common salt or cane sugar dissolves readily in water but not in benzene. Naphthalene or camphor dissolves readily in benzene but not in water. In general, a solute dissolves in a solvent if intermolecular interactions are similar in the two substances. Like dissolves, like the principle of solubility. The solubility of a solid or liquid is markedly influenced by temperature. This influence can be explained based on the Chatelier's principle. In a nearly saturated solution, if dissolution process is exothermic, delta H solution is negative. Solubility decreases with increase in temperature. If the dissolution process is endothermic, delta H solution is positive. Solubility increases with increase in temperature. Since solids and liquids are highly incompressible, pressure has no effect on the dissolution of solids and liquids in liquid solvent. Many gases are soluble in water. Dissolved oxygen is very less, 5 ppm in water, but this amount of oxygen sustains all aquatic life. Solubility of gas in water generally decreases with increase in temperature and increases in pressure. With an increase in the pressure, the number of gaseous molecules per unit volume over the solution increases. The rate at which the gaseous molecules striking the surface of solution to enter into the solution increases. The solubility of gas increases until a new equilibrium is reached. Henry was the first to give quantitative relationship between the solubility and pressure of gas, which is known as Henry's law. The law is stated as at a
So, do the temperature has an effect on the solubility of liquids? What is meant by supplying the temperature? How the temperature increases of a liquid when you're heating up a liquid, when you're heating the water, and in the water, if it is very hot, do the sugar it it is soluble? Yes, in hot water, it is soluble quickly. It dissolves. It dissolves quickly rather than in cold water. Okay, sugar dissolves quickly in hot water. Do yes, temperature have its effect on the solubility also. The usually we have seen if liquids, if they are heated, the particles they move very fast until they overcome the force of attraction between them, isn't it? The temperature at which this happens is called as the boiling point. Boiling point. Above the boiling point, the liquid gets converted into gaseous form. Okay. So here, when heat is supplied to the liquid, the molecules start vibrating. Okay, so here we'll see what are the factors which are affecting the solubility. So I'll just say a few words regarding this solubility, children. So how actually, what happens if temperature is supplied to this? What happens in the case of solubility? Usually what happens when we mix solid into liquid? What happens when we mix a solid into liquid? The solid dissolves in the liquid. It's called as a solute. We have just will discuss about this solute, what is solvent, and what is solubility. And then we'll go further into the factors which are affecting the solubility. Okay. So actually, what is solubility first? The maximum amount of solute that is being dissolved in, in the known quantity of a solvent. What is the known quantity of solvent? If you are taking 1 glass of water, we know the quantity of water, how many ml we have taken. Okay. So we are dissolving the amount of solute. We have taken 1 spoon. We are measuring it and taking, and we are dissolving it in the solvent at a known temperature. So it is called as solubility. Okay. So the substance which are dissolved inside in the solvent, the substances which dissolve in the solvent, such as water. The solvent is water here. That type of substances are called as soluble substance because they are soluble. Why? They are dissolved completely in the solvent. When the mixture is made up of solid in a liquid, when you are mixing a solid, sugar is in the form of a solid crystals, isn't it? It will be either produce a solution or a suspension. It will produce a solution or a suspension. It depends on the solid which you are mixing in it. It depends on the solid which you are mixing in the liquid, in the water. When a solute dissolves completely in a solvent, it results in a clear solution. If you dissolve 1 spoon of salt or 1 spoon of sugar in water, 1 glass of water, can you see it? No, you cannot because it is completely dissolved. Now it is called as a solution. What is a solution? Can you tell me now? What is a solution? When a solute is dissolved completely in a solvent, it results in a solution. Yes, can anyone just tell me what is the solution now? Yes, keep your camera on. Srihit, Tanushree, Srinika, Aishmita, keep your camera on. Yes, can you tell me what is the solution? Bhuvan, what is the solution?
Solution is a mixture of solubility and solvent, ma'am.
What is the definition? When a solute dissolves completely, what results in solution? How a solution is formed with a mixture of? Yes, anyone? Manogna? Keep your camera. Manogna, are you there?
Yes, ma'am.
Yes, can you tell me what is a solution? What is a solution? Is my voice clear to you all?
Ma'am, it is not. It is very low, ma'am.
It is very low.
And sometimes it is choking, ma'am.
Yes, Divishi?
Ma'am, no, ma'am. Your voice is not stucking, ma'am. I think for her network problem.
Okay. So a solution is nothing but when a solute is dissolved completely into a solvent, it results in a solution. A solution is nothing but a solute dissolved in solvent. Okay. If a solution is clear, it will not settle down any substances down. If the solute is not dissolved like sand, if you're trying to mix sand in water, do sand mix in water? No, it will settle down in the water. It is not mixed. like sugar and salt, it will not dissolve. It will settle down in the water. So here, when a solute doesn't mix properly with the solvent and results in a cloudy mixture, it is called as suspension. It is called as suspension. Now we'll see what are the factors affecting the solubility. Factors which affect the solubility. Firstly, we'll see the homogeneous mixture. What is a homogeneous mixture? A mixture of two or more substances is known as a solution. So here I'll show you one video for a homogeneous mixture, solubility and its factors. Okay, so that you can understand it properly.
Solubility and factors affecting solubility. Nature of the solute and solvent. In general, polar and ionic solutes tend to be more soluble in polar solvents. Non-polar solutes tend to be more soluble in non-polar solvents. Inorganic acids, bases, and salts, which are ionic, tend to be much more soluble in water. Solvents such as carbon tetrachloride, hexane, and benzene, which are non-polar, these are not soluble in polar solvents. Gasoline is non-polar substance, slightly soluble in polar water, but highly soluble in non-polar carbon tetrachloride. By observing the above cases, we can conclude that polar and ionic solutes are soluble in polar solvents and non-polar solutes are soluble in non-polar solvents. The generalized statement is like dissolves in like. Effect of temperature on solubility. Most of the solutes have a limited solubility in a given amount of solvent at a fixed temperature. The temperature of the solvent generally has a marked effect on the amount of solute that will dissolve. In case of solids dissolved in liquids, the dissolving process is endothermic and an increase in temperature results in an increase in solubility. For example, the solubility of soap and dirt in hot wash water is greater than in cold wash water. In case of gases dissolved in liquids, the dissolving process is exothermic and increase in temperature results in a decrease in solubility. For example, when water in a kettle is heated but not boiled, dissolved air escapes and it becomes less soluble at high temperature. Therefore, an increase in temperature increases the solubility of solids in liquids. An increase in temperature decreases the solubility of gases in liquids. Effects of pressure on solubility. Effect of pressure on solubility is very little in case of solubility of solids in liquids. Effect of pressure on solubility has a marked effect in the case of.
Yes, Kaushal, what happened? Why you have raised the hand? Kaushal?
Gases in liquids. The solubility of a gas in a liquid is directly proportional to the pressure of that gas above the liquid. For example, when a bottle of carbonated soft drink is opened, the pressure is reduced and dissolved carbon dioxide bubbles come out of the solution. Therefore, changes in pressure have no appreciable effect upon the solubility of solids in liquids. The solubility of gases in liquids is directly proportional to the pressure of gas above the surface of liquid. Henry's law.
Yes, children, just 1 second. I'll just stop the share. Yes, so here we have seen the factors which are affecting the solubility. So in the case of a homogeneous mixture, just 1 second. I'll just keep one more video for you regarding the solubility. 1 second. So here we have seen, I'll just explain it to you about the homogeneous mixture, children. Yes, Divishi, any doubt? Yes, Devishi.
Ma'am, means this solvent means if in means in water which will dissolve, it's called solvent, ma'am.
Yes, it is solvent which will dissolve. Water is a universal solvent because it dissolves all the things. Okay, I'll show you one more video regarding this. So we have seen about the solubility of solutes, the temperature, how it affects the solubility. If the temperature is increased, temperature of the solvent is increased, the intermolecular space between the solvent molecule increases on heating. More amount of solute can be accommodated in between these spaces. There are molecular spaces in liquid, more molecular spaces are formed due to heating. So because of these more intermolecular spaces are there due to heating, more amount of solute can accommodate, can go and dissolve in the liquid, in the water. Okay, so by stirring, what happens by stirring? When we just keep sugar in the water and we stir it, what happens while stirring? Stirring moves the solvent molecules. This allows them to interact with the solute particles that remain undissolved and help them to dissolve in solution. That's why we stir. After pouring 1 spoon of sugar or salt in the water, we stir. Why do we stir? Solubility increases by stirring. Okay, clear?
Yes, ma'am.
So now size of the particles of a solute. Size of the particles also matter in this condition. If the size of the particles are very big, then it will take a lot of time for the solute to resolve in the solvent. Now, for example, take sugar. If the sugar molecules, if the sugar is crystals are very big, can it dissolve fast? Can it dissolve? Can sugar dissolve if the sugar particles are very big? No, because they are small crystals. They can dissolve quickly. Now, if salt crystals, salt is big, salt crystals are big, then can it dissolve quickly? No, it takes time to dissolve. Slowly it will dissolve. So the size also matters. If the size of the crystals, sugar crystals are small, if you still grind it into powder, if you still grind the sugar into powder, it will dissolve quickly. Okay? So here, size of the particles of a solute also matter. If the size of the particles is very small, then it will dissolve in the form of a powder. If it is in the form of a powder, then it will dissolve quickly. Okay, is it clear? Any doubts? So now coming to solubility factors, children, a homogeneous mixture of two or more substances is known as solution. A solution has a solute and solvent inside it. Okay, a solution. What do a solution have inside it? A solution have solvent and solute both. What is solvent here? Solvent is the water and solute is the substance which you are mixing. Either it might be sugar or salt or anything. And solvent is water. The mixture of two. Solution has both solute and solvent. Okay. Solution has two things inside it, a solute and a solvent. A solvent plays a major role in the solution while a solute is added to the solvent. Solubility is the property of a solid, liquid, or gaseous chemical substance called solute. Either it might be a gas, or it might be a liquid, or it might be a solid, which is being dissolved in the water, in the solvent. So the solubility is the property of all these three states which are dissolved in water. Okay. In sugar solution, if you are mixing sugar in water, the formation of sugar solution is only a physical change, as dissolved solute can be recovered by evaporating the water. By evaporating water, you can get back the sugar. Okay, it will be left over because the water, it evaporates completely. It goes in the form of vapor. But sugar, can it? The dissolved sugar, it stay back down at the bottom. Okay, and even in the case of salt also. So here in this case, what happens at this? So this state is called as saturated solution at room temperature. When sugar is mixed in water, it is able to dissolve. Water is able to dissolve the sugar inside it. The solution at this stage is known as saturated solution because it is dissolving completely at room temperature. Okay. When you heat it, what happens? When you heat the water evaporates. And what left out? The solute which you are mixing, either it might be salt or sugar. When water evaporates completely, what happens? What left over? What remains down? Yes, Diksha. When water evaporates, when you heat the water, when water evaporates completely, what is remaining down? What left over? Yes, Trishika. Can you give me the answer?
Sorry.
Anvita,
Mama.
Anvita, can you?
Mama.
Yes. Anyone? Just raise your hand. Trishika?
Yes, ma'am.
Yeah. What happens when the water is completely evaporated in the form of vapor? The solute which you are mixing, what happens to the solute? Yes, anyone from you? No one. We have already learnt in our previous class. Yes, Harsh.
Ma'am, solute will be left, ma'am.
Solute will be left. Okay, good. So we have already learned in our previous class. In which lesson you have learnt it? Evaporation, condensation. You have learned? You have learnt in the previous class. Reversible, irreversible changes we have learned it, isn't it? When the salt, it remains down, sugar solution and salt solution, is it a reversible change or irreversible change? I have asked you. Okay, so here we were talking about the solubility. So when water, we heat the water, so we know that water evaporates in the form of vapor. So when this solute is mixed, so what is the conclusion of this, children? So this solution, when it is completely dissolving, when the sugar is able to dissolve in water completely, this solution is called as this, at this stage, it is called as saturated solution, because sugar is